or practice? Okay.
I did.
You forgot to. Well, we're going to review a little bit here, but the whole point of that is to kind of try to help you, okay? I want to start this morning with a joke. I know you guys love jokes so much, okay? Now, you all notice Mrs. T has moved around the room.
Yeah.
Has anyone ever noticed her plants?
Yep.
Okay, does anybody know what has happened to her plants
Her plants have died.
since she started teaching radicals to you?
They've gone down.
They've gone down?
My grade.
Just like your grade. No, her plants have grew square roots. You guys are hilarious. Just look at these pictures I have real quick. What is the square root of 4? 2. You see? Oh, yeah. This is a literal square root. There you go. Happy Square Root Day. That's what today is. Notice there's 2 of them. We're going to talk about how to put those things together today.
Really happy square root day?
Yeah.
It is.
Another literal square root. And then this is every young person's personal favorite.
Oh, mine.
The square root of the answer. You see that?
I like that.
Yeah, it's a square root symbol. All right. Who knows what this is?
It's a nautilus.
Selfish.
A nautilus. Very good. Okay. This is a nautilus. The reason I put this on the screen today, they live in the ocean and they're real funny looking. But if you were to cut that open, on the inside, you get this shell that has a perfect geometric pattern. And this pattern, scientists and artisans have actually discovered you can create when you take square root measurements and you add them together, okay? So I just want to show you this to let you know that all that you're doing, this math, and sometimes kids ask, what's the whole point of this? You know what? God created math, and he employed it when he created things, and people do the same thing with square roots. They have discovered this pattern. They use this for pictures and to build buildings, and so square roots are not without a purpose, okay? Let's start to review. Basically what we're going to do today is we're going to add square roots, and in order to add those, you have to do 2 simple things. You have to simplify, and you use the distributive property to combine like terms. Who can come to the board and simply underline the like terms in this expression? Come on, like usual, just hop up here. Underline the like terms for me. Okay. Does everybody agree?
Yep.
Okay, are these the like terms? Very good, that is correct. The 4x and the 2x are the same. Notice they're the same because of the variable. They both have an x. Luke did not select these because we have a y and we have a z. What about in this expression? Can someone come and underline the like terms? Okay, now he was very quick to do this. 3a, and what is this term here?
A.
Is it a?
1A.
1a? Okay, so we can put a 1. Say it again, Shane. Negative 1a, okay? That's going to be important in the lesson today, that as you start to combine like terms, that you do not forget the negative symbol that may be in front, all right? And then this expression here, you only have 2 terms, and you can see already that they are both like terms, but who knows how to combine those? What would the answer be there? 2x plus 3x.
5X.
5x, very good, I agree. My question is, how did you all arrive at that? Okay.
You don't add the x.
Very good. 2 plus 3, we don't add the x because what? We're not going to multiply it. Now, let me reiterate this because you all just did something excellent, which I'm hoping that you continue to do. You did math right here all in your brain, okay? If you had to factor out a common term, what would it be? X, okay? If we took out an x, that leaves us with 2 plus 3. Everybody see that? Does that make sense? Okay. What is 2 plus 3 in this quantity? 5. So we now have x times 5. And if we rewrite that, it's 5x. So you all were able to look here and go immediately here, and you did all of that distributive work inside of your brain. Okay. That's the same concept that we're going to do with radical expressions, is you're going to use a distributive property to match them up, the terms that you can add, and then you'll simply simplify. And all of that, again, is happening on the inside of your brain. Does this make sense so far? Yeah. Okay. I want to give you a definition. Write this down, please, in your notes. Okay. In order to add radical expressions, you have to have like radicals. Like radicals. Okay?
Add what?
In order to add radical expressions, you have to have like radicals. And like radicals means that both terms have the same index and the same radicand. Now, if I put this on the board or on the wall, who recalls what is the index?
X.
The x, very good, okay. What could the x be?
2.
2, okay, square roots. What else could it be? 4, okay. 3, cube roots, all right. 25, all right. Now, usually I don't think you guys have had anything above 9. But yeah, so the x's have to be the same in order to combine those, but also the radicand. So if the x is the index, what term is the radicand? The a, very good, okay? So they have to be the same. If I had the square root of 3 plus the square root of 3, can I combine those? Yes, I can, all right? If I had the square root of 3 plus the cube root of 3, am I able to combine those? No, not based on the definition because my indexes are different. Does that make sense? Okay, remember that point because that's the whole gist of this lesson. Now, one more thing for review, which is what was in your homework, okay? I need someone to come and to simplify this radical. Does anybody remember how to do that? Remember our other lesson? We talked about jailbreak, the thinking method, or you could do the very, very long route. You remember how to do that? You all work it out on your paper as Shane does it on the board. He looks at me for confirmation. Look at your classmates. What do they tell you?
It's fine.
You guys agree or disagree?
Takes 2 to break out.
Okay. Very good. He did the jailbreak method, everyone. He took 45 and he broke it apart. Remember I said if you think real quick, I'm thinking 9 times 5, right? And 9 can be broken into 3 times 3 and then times 5. And because this is a square root, how many inmates does it take to break out of jail? 2, okay, but who survives? Only 1 survives because the other one got shot. So we have a 3 left over, and what is inside the radical symbol? A 5, okay, so this is 3 square root of 5. Can someone come and do this here? Beautiful. You said you didn't do your homework. That was it. Okay, does everybody agree here? Again, 3 times 3 times 2 gives us 18. It takes 2 terms to break out. We have a 3 left over, and this is the square root of 2. So on some of these expressions that we add today, in order to get it in this form, you will have to simplify those radicals. Okay? Does everyone have a calculator?
Yep.
All right.
My best friend.
Just have it on your desktop because I'm going to let you use a calculator today to cheat in some instances, okay? It's just to be efficient and to save time,
We get
okay?
to cheat and manipulate.
You get to manipulate the numbers and cheat. Great, all right? Let's start with some actual examples of how we are going to add radical expressions. Here's your first example, everyone. Please put this down on your paper. 4 times the square root of 3 plus 2 times the square root of 3. 4 times the square root of 3 plus 2 times the square root of 3. Is there someone brave enough that says, oh, I got this, I can add this? JB, you look like you want to do it. Yes, no?
Come on, JB.
Okay, come on, Shane.
6 square root of 3.
Okay, 6 square root of 3. How did you do this?
Well, the square root is the same, so, or whatever, the radicand is the same, so I just left it, and then just added the, what was on the outside.
Very good, very good. That's exactly it. Notice what I did, everyone. If you had 4x plus 2x, what would that be? 4x plus 2x? 6x, okay? The x basically is in the position of our radical term. It is the square root of 3. It is the square root of 3. So all we really have to focus our attention on is this term in front of the radical, the 4 and the 2. And because this is addition, 4 plus 2 is indeed 6 square root 3, okay? So this problem here did not involve any simplification, all right? It was already simple enough. All you had to do was look and combine. And again, if you think carefully, everything that Shane just did, he did the distributive property in his brain. This would be 4 plus 2 times the square root of 3. 4 plus 2 is 6 times the square root of 3. Does that make sense? Okay. Let's look at this second example that I have for you. We had that on the board. All right. The square root of 45 plus the square root of 18 minus the square root of 5. And remember, there's only 2 steps to adding like radicals. Simplify and then combine like terms. Do we need to simplify here?
Yeah, which we've already done.
Okay, which we just did in your notes. So who can give me the answer to this? What is the square root of 45 simplified?
Square root of 5.
Thank you.
And then plus 3 square root of 2.
And then this term here, what is it?
It stays the same.
Okay, very good. It stays the same. What's the invisible term that we have here? 1. Very good. I want you all to remember that. There's a 1 sitting in front of this square root of 5. All right? Who can come to the board and write down what this is going to be simplified? Okay, when we combine all the like terms, what will we have? Come on, George. Write it down right here.
But not all the radicals are the same.
Very good. So you'll combine what terms you can. Just like in this top expression, we would have only combined the 4x plus the 2x. All right. What do we think?
Yeah.
Now, I'm not sure how you guys learned when you first started to combine like terms, when it was just with variables, but anybody remember having to box them or to circle them just so you would see what they were? Okay.
Question worksheet.
And you had to do that? Oh, my goodness. If that helps you on this lesson, please do that just so you don't miss anything. George didn't miss anything here, but he did combine them correctly. The 3 times the square root of 5 minus 1 gives us 2 square root 5. And then that leaves us with 3 times the square root of 2. Notice we cannot combine these because our radicands are different. Okay, they have the same index, okay, but the radicands are different. Does that make sense? Yes, no, maybe so?
Yep.
Okay, let's keep moving forward then. I want to give you another example and have someone come to the board and see what you can do with it. Negative 8 times the cube root of 5 plus 9 times the cube root of 40 minus 2 times the cube root of 135. Write that down and let me give you some suggestions before I invite someone to the board. No, Shane is itching to use a calculator. Everybody have that down?
Yep.
Okay, let's look at each individual term. Does it look like we can simplify anything here?
No.
Okay, no, this is already a prime number. What about here?
Yeah.
Okay, what 2 terms should immediately pop in your head?
4 and 5.
8 times 5 or 4 and 10, okay? Now, because this is a cube root, we want to try to pick something that we know we can put inside this radical symbol and it will reduce immediately. Out of the 4 and the 10, or the 8 and 5, which one of those is going to work?
Cube root of 8.
Okay, the cube root of 8. Everybody remember that chart that I gave you the other day?
Yeah.
Do you still have it? Pull it out.
Somewhere.
Somewhere?
But the cube root of 8 is
The cube root of 8 is? 2. Very good. Okay, so that's going to be very beneficial for us. So we want to write this as 8 times 5. Everybody see that there? We'll rewrite that term as 8 times 5. And then at the last one, and this is where you can go ahead and we'll start to utilize the calculators appropriately, okay? 135. Now, I'm not that bright, okay? I have no idea if this is a perfect cube off the top of my head if I don't have that chart memorized. But what could I probably do to reduce this? What term would you immediately want to throw in there? 5. Okay, so use your calculators, everyone, to do 135 divided by 5. What do you get? 27, okay?
27.
So, very good. So we see that right away,
Which is 3.
that 27 is able to be put under this and it will reduce perfectly. Now, if you like the jailbreak method, okay, I'm not opposed to you using that, but again, that'll take you just a little bit more time. But what you'll basically see with the jailbreak method is 2 times 2 times 2, right? How many 2s does it take to break out of this jail? 3. How many will survive? 1. So we have a 2 here. We still keep the 9. Notice we pull the 2 out, and it's going to be multiplied times the 9. Everybody see that? Okay? So we still have the cube root. What's left in the jail? 5. Same thing over here. This was 3 times 3 times 3. How many 3s does it take to break out?
3.
Very good. Only 1 survives. So this is negative 2 times 3. Everyone see that? And what do we have left? Okay.
The one is simplified.
Very good. The other one is already simplified. So now this expression looks totally different than what we started off with, but we're doing all this work, so eventually we'll be able to get an answer. I do want to point out the multiplication. Don't mix up your index with something that you're multiplying. Don't mistake this to be an exponent, okay? Please take the time to write all your work out and then go back through and a step at a time. If you get too busy with these numbers trying to manipulate them in a hurried fashion, you're going to get a wrong answer, okay? So let's work on this here. What is 9 times 2? 18, okay? What is negative 2 times 3? Negative 6.
But can't you just change it to positive? Because it's minus a negative 6. Right?
This was always a negative here, a minus, a minus, a minus, a minus. So if you just want to write down that minus, and you can do 2 times 3 and you'll still have the minus. All right, now I need someone who's brave enough to come, and now all you have to do is the addition. You're going to add these things together. Here, give us nice and black. Oh, that's a plus. I'm sorry. I didn't write down the plus. This is plus. Okay, let's see. Negative 8 plus 18 would be 10.
Minus 6.
10 minus 6 is 4. Very good, okay? So notice you didn't need a calculator for that. That was simple math that we could do, but we did use the calculator appropriately with the 135, okay? Now you probably could, on a piece of scrap paper, divide 135 by 5 and you'd be okay, but just for efficiency's sake and to save time, all right? Does that make sense? Anyone have any questions so far? Everybody get the same answer Manuel got? Yeah? All right, let's go and do another example then. Two x times the square root of 50x minus 5 times the square root of 8x cubed. And again, this needs to be simplified. Is there someone willing to come and show us your work on the board for this? All right. Everyone else start working this on your paper while he's working it on the board. Pause. Oh, yeah, that'll work too. Go ahead, keep going. Very good. Do the same thing with this too that you did with that. If you write it out, because then you can use the jailbreak method. Mm-hmm. All right, and he boxed his final answer. George got 0. Anyone else get 0? Shane? Yeah? Okay. No, you did not? All right, let's walk through. I rewrote this over here again because I'm going to walk through and go over some of George's thinking, which is good because he was doing a lot of this in his head and working through the process. So you know these need to be simplified. Okay, looking at the radicand 50x. George decided to go ahead and break it down into 5 times 10, which is fine because he continued to break it down until he only had these prime factors. And that works really well for the jailbreak method. The other thing that he could have done here, and I'm just going to show you over here, is 2 times 25 times x, okay? Because which one of these can be immediately simplified with the square root? The 25, okay? And he can pull out a 5, which is what he actually ends up pulling out here, okay? So there's not necessarily a right or a wrong way. There is a right or a wrong answer, okay? And so he was able to get the answer. So we're going to pull that out. And what we have left under the radical is the square root of 2 times x, all right? For this second term, again, he did the same thing. He broke it down till he only had prime factors, which works as well again, okay? But you also, and I just want to stress this for the thinking method, this is a square, right? Okay. 2 times 4, x squared times x, all right? And basically, we're just saving one step from the jailbreak method. 4 can be reduced to what? 2. X squared can be reduced to x. And what do we have left in the radicand? 2x, okay? All of the rest of his work is correct. The multiplication, okay, I would do just the same. And when you go ahead and combine these, you end up with 0, okay? Who likes using all of the prime factors, okay? I like to use that one when the numbers are bigger and maybe I'm not necessarily certain. Who likes to do what we call the thinking method again, okay? Now, the reality is, and I've kind of manipulated you guys in teaching this math, you have to think to do this, right? So this is thinking, and you have to know prime factors to do this, okay? So either way it goes, you're thinking and using prime factors. Whichever way comes easiest to you, that's the way I want you to do and to practice, all right?
It's fun thinking about people breaking out of jail.
It's fun to think about people breaking out of jail, especially when one criminal gets shot. Right? All right, one last example for today. Any questions so far? You think you all can handle this? Yeah? Okay. Let's look at the square root of 2x squared plus the square root of 75x to the fourth minus 2x squared times the square root of 3 minus x times the square root of 18. Do I have a volunteer?
Yeah.
Sit down. You just were up here. Do I have another volunteer? Someone brave. You're going to go? All right. Everyone work this out on your paper while Shane does it at the board. Use a beautiful blue.
It's easy, it's just long.
It is long. Very good. And if you take it a term at a time, you'll be okay. Hey, you're on the camera. Be a good student. I don't want to slap you with the camera.
That was the camera.
I'm getting it done.
Jailbreak. I like
Yep.
it.
Okay. What's on your third?
Oh, I like this. I like how you conserve space right here and do that now. Are you done yet?
I'm getting it, bro.
All right.
Alright, so,
Do me a favor. Will you underline your like terms in two different colors? Just so they can
the
see.
like term?
Yeah.
What?
The whole thing. This whole thing. Based on your radicate, remember?
Oh, yeah. Now go back again.
Mm-hmm. All right, you have one fan, Shane. Oh, two fans.
The party now.
Anybody else joining his fan club for the answer? Where you got?
I just something wrong.
You went from here to here. Where'd you get the 3?
25 times 3.
Yeah, that's right. This was, that just stayed the same. What'd you do here? Oh, you didn't go all the way over. Yeah. So if you reduce 18, the square root of 18, what does that become? Say that again. We'll talk about it in just a second.
Well, we all got it.
You probably have the answer on it the other way.
What's the other way?
Well, like, that way they're not negative, like it's minus.
No, I don't think you have to. That's really not a problem. You, at this point, you all can handle a negative term. It
I
doesn't.
didn't know because the x, the squared is higher than the, so I didn't know if you had to write that.
Oh, I see what you're saying. No, I don't think there's a particular
It
order.
doesn't make any difference, but I
No,
didn't know.
no. What probably would make a difference, let's pretend here for a second that maybe the squared term was y's, if these were y's.
Okay.
Then,
So I got it wrong.
no, remember our rule, about, we always want to list the terms in alphabetical order. So then, yeah, this would be first, and this would be a y.
Yeah.
Okay. And vice versa if these were y's,
That
but
doesn't make any difference.
no, it doesn't make a difference. No. All right, so let's look at Shane's work just to verify if we think he is correct or not. X squared means we can take out an x, and this leaves him with the square root of 2. 75, he does the jailbreak method, 3 times 5 times 5. Did anyone do 3 times 25 and just reduce 25 immediately? Okay, very good, very good. The thinking method, jailbreak method, same concept here. So he's able to extract a 5, and also notice that x to the 4th is x squared times x squared, okay? That also could be x times x times x times x. And in this particular scenario, how many inmates does it take to break out of jail? 2,
Well, see, I
okay?
did the jailbreak, but I don't think it was necessary to write out. Because it's an even number, so.
Very good, very good. You didn't have to do that. But even here with this concept, you need 2 inmates, and if these 2 broke out, only 1 survives, which is what he has, okay? So we end up with the 5x to the squared times the square root of 3. Look at this problem here. This is already simplified, correct? So all you had to do was rewrite it. And over here, again, 2 times 3 times 3, which is also 2 times 9, and the square root of 9 is 3. All right, so that 3 times the x gives us 3x. And then I had Shane to underline his like terms, okay? Please, again, remember to focus and to do that if you need to. Sometimes it just helps even if you pick the ones you're going to add and underline those. And so you kind of see what's left. He used 2 different colors, so we know these are the ones we have to combine. And you're not, again, you don't have to write out all the distribution because you're doing it in your brain. X and negative 3x give us a negative 2x, okay? And then 5x squared minus 2x squared gives us a 3x squared, okay? Yes, I think this is the correct answer. Everybody agree? How many got the same answer? Okay, 100%. Very good, guys. Very good. All right, that's the general gist of this lesson, and you have about 20 minutes to get started on it. Any questions? Okay. Does anybody need any more practice? Okay. Let me show you something real quick with your calculators, just so I can help you to use them correctly.
Is there a wrong way to use it?
Yes, there is a wrong way to use a calculator. The wrong way to use a calculator would be when you have this on your paper and you take 2 minutes to type this into the calculator to find out what it is. Okay? That's the wrong way. Calculators were invented to be an efficient means for us to quickly do mathematical computations. But when, you know what? The calculator is not as smart as your brain. Okay? Why? Because someone's brain made the calculator. So learn to use your brain, all right? On your calculators, everyone, I want to particularly give you license today. Open up your books to page 454.
Get our books out.
454?
Is that not the right page? Yeah, I think you're on 454.
Okay.
That's way back there.
We've just been so studious.
Oh, you all just had a week off and totally forgot what page in the book we were on.
Well, I didn't know the first place.
I didn't know we were that far.
I didn't know
Yeah, you're that far. This is chapter 11, guys.
That's more.
It's 11.5, man.
Man, it looks like we're gonna get done with the book.
Yeah, actually, finally, the first book I've ever completed in my life.
Besides sitting on the toilet.
Well, honestly, I'm serious. Like,
This will be the first book you've
Yeah,
ever
really.
completed in your life.
and Will is school-wise.
Yeah.
Will is just like skipping on stuff.
All right, I want you all to scan the problems on page 454 and 455 and look for very large numbers, particularly under cube roots or fourth roots.
Number 12.
And someone give me one, he said number 12, another one even, where you think maybe we would use the calculator, okay, in that respect.
Number 21.
21, 22, 26,
26.
29.
Okay, number 12, I agree with number 12. Say it again, guys.
12, 21, 22, 20.
Okay, 22, 29.
26.
Not 26. 26 is not.
Oh, 29, I don't think you need
26
to.
is long, but it's like
26 is
35.
confusing. But still.
Can't even use a calculator either.
No, you can't.
Number 29?
All right, let's focus on 22, everyone. Okay, 22. And you see here I have my calculator on the board.
Oh, yeah, I like
Okay. You all have the very first term. Everyone please look. This is 3 times the cube root of 108. Okay. 3 times the cube root of 108. Okay.
Type it in.
No, you don't have to type that in. Remember, because that's not what we're doing. I want to show you how to use it efficiently. So we want to figure out here, okay, what we can break this into that's going to give us something that is indeed a perfect cube. Okay, you have your chart that you can also look at. What would I divide 108 by?
3.
3,
You
okay.
get 36.
And you get 36. Is 36,
Divided by 6, 12 and 9.
Yeah, 6 times 6.
6 times 6,
That's
which is
not perfect.
that's not a perfect cube, okay? So that doesn't work. Can we think of something else? Divide by 9, very good.
12 and 9.
12 and 9,
12.
okay?
12 divided by 2 is 6.
3 times 3 times 3 times 3 is something.
Either way,
Yeah, it means
Okay.
3 times 3 times
Very
3
good,
times
very
4.
good, very good, okay? So if we did the 108 divided by 9, 9 is going to give us that other 3, right? And then it'll leave us with the 12, okay? So if you happen to get a term that you're not sure, 9 you knew, but I want to give you a very simple one, go ahead and enter into your calculator the cube root
whoa, that's a little scientific.
of 9, whatever 2 factors you would get, okay, you want to determine if one of them is going to, yeah, the cube root of 9,
Got that.
and what does it give you?
It gives you 2.08.
0.080083.
Okay, so does that work?
No.
No, okay, we don't want a decimal, all right? So 9 and 12, all right? Keep thinking with me.
Square root of 9.
15.
That's fine.
15.
36.
Can someone please pull out their chart that I gave you guys?
I didn't walker.
Oh, I had to print you off one.
Got a chart.
300.
Hey, 6 and 18.
324.
I have it here somewhere, don't worry.
I guess that's not the answer.
There you go, beautiful.
27.
27 and what?
3. 4.
27.
Where's the 4?
All right, does that, someone do the math. 108 divided by 27.
times 4.
Thank you, okay. So wait, everyone listen here. Do you see how entering that in shows us, we don't want a decimal. Luke just came up with 27. 27 divided by, 108 divided by 27 leaves us with a 4, okay? So it's 27. What's the cube root of 27?
9. Oh, 3.
3, very good. 3, all right? So this is the intent for the calculator, all right? To help you not to have to be swimming for a whole bunch of numbers.
We're going to finish the problem.
No, we're not going to do the whole problem. I just want to show you that one term. Good job, though, okay? So use your chart, use the calculator to help you to simplify things so that you can get like radicals that you can add. All right, any other questions? Okay, you may get started.
On what?
Thank you for this day.
Your lesson. Everyone wave at the camera. Tell James thank you.
Bye.
Hi, James.
Thank you.